Good afternoon, all. Myself, Dr. Mrs. Archana Dehankar, working as an assistant professor in Computer Technology Department, Priyadarshini College of Engineering, Nagpur. This session is intended to provide the brief introduction to the course on operating systems, which is usually studied in fourth semester computer technology. This is also studied in every branch of computer science. It is also included as a part of GATE syllabus. The code for the subject is BECT 406T. As everyone knows, that is computers, they are prevalent in every application, ranging from the games which are made for children to the more sophisticated applications which are made for the multinational firms and etc. Without software, a computer is a useless lump of metal. So software is very necessary. So software can be roughly divided into two categories. That is the system programs and application programs. System programs which are meant for the operation of the computer system, and application programs which are meant for satisfying the requirements of the user. So most fundamental system program is operating system. So actually main aim of the operating system is for the convenience of the user as well as for the efficient operation of the system. So as the next slide is why OS. That is why we have included OS as a subject for any computer science student, as it is the most important software which runs on the computer. It acts as the intermediary between the user of the computer and the computer hardware. It also provides the environment in which the user can execute programs in a convenient and efficient manner. It acts as a resource manager, as it manages the computer hardware. As everyone knows, hardware means the processor, memory, the network interfaces, IO devices. So these are managed by the operating system. It is a layer of software which is on the top of the hardware, that is, which will be shielding the programmer or the user from the complexity of the hardware. So this can be what is the role of the operating system in any computer system. It can be explained with the help of this block diagram. So as we can see in the diagram, at the lowest level is the computer hardware, and whatever are the application programs, as we can see, that is there may be the spreadsheet, word processors, compilers, web browsers. They define the ways in which these resources are used to solve the computing problems of the users. A user interacts with the hardware through the operating system by writing several application programs. So operating system, what it does, it controls the use of the hardware among the various application programs for the various users. So it is the intermediary between the user of the program, user of the computer, and the computer hardware. So what are the objectives of this course? So as we know, as just we have discussed, that it is providing the crucial interface between a computer's hardware and the applications which run on the computer. So it allows us to write the programs without bothering much about the hardware. It also ensures that whatever are the computer's resources like CPU or processor, hard disk, memory, how they are, utilized, whether they are utilized appropriately or not. And the course, it discusses how the OS manages to do all this in the efficient manner. OS is not a single program. It consists of several modules, and each module will be taking care of different components of the hardware, that is processor, hard disk, memory. So as in the syllabus, there are different units which will be taking care of each module of the operating system. And why this major objective of the course, that is, once you are going through the fundamentals of the operating system, students gets equipped for taking up the challenges in understanding and designing of the computer system. So this course will be addressing all the fundamental points, which will be starting from the foundations to the architectural issues to correlation with the existing commercial operating systems. Next slide, as you can see, it is application of the operating system in the real world. As everyone knows, computers are being used everywhere. Yes, in banks, schools, hospitals, companies, everywhere. And no device can operate without an operating system because it controls all the users' command. As we are using the Linux, Unix operating system, which are very secure operating system. Then everyone is using the smartphone, where we are using the Symbian OS, then iOS, that is different operating systems which are made for operating the mobile phone. So so everywhere there is a role of the operating system. What are the syllabus contents of this course, which will be covered in the fourth SEM of computer technology according to the new syllabus. So unit 1, it is covering introduction to the operating system. That is what the operating system is, what functions it performs, what are the different types of operating system. You must have heard about the real-time system, distributed system, then multi-processor system. So these are the different types of operating system. Then how this system, then how this services, that what are the services which are provided by the operating system, how they can be accessed by the use of the system calls. Then there is a concept of process, that is, when we are writing a set of instructions to solve the problem, then it is a program. But when the program is in execution, then it is called as the process, because while program is being executed, it will be requiring several resources to be allocated. That is, before execution, program must be brought into main memory, and then it is allocated processor. And if there are more than one program running on the computer system, then what is needed is that the resources are being shared. So there is the concept of process is there, and the process during its execution, it may go through the different states. Okay, and then there are different types of schedulers. Then there is a concept of thread, that is most of the modern computer system, they are providing the features so that the process will contain the multiple threads of execution. So there is a multi-threading approach which we are following. So these all will be covered, this all stuff will be covered in the unit 1. Then in the unit 2, as what is the major goal of the operating system is to maximize the utilization of the processor. Because when the processor, very important resource of the computer system, it should be utilized properly, and it should not be idle. It should be utilized properly, and there must be some program running at all times on the processor. So there is a concept of multi-programming, means multiple programs in the main memory, so that CPU can switch from one process to another. So there is a role of the processor. Being processor as the primary computer resource, its scheduling is very necessary. So the concept of CPU scheduling, what are the different algorithms of scheduling? The scheduling algorithms like FCFS, then priority scheduling, round robin scheduling, SJF, that is the shortest of first scheduling, it will be covered in the unit 2. Then, as I have just told, that is when there are multiple programs in the main memory simultaneously, they must cooperate with each other. Yes. So they must communicate with each other. So that is the inter-process communication. So process synchronization, there are different methods for process synchronization. So that the process must cooperate with each other if they are sharing some data, they are sharing some logical address space, so that the data consistency is maintained. So that will be covered in unit 2. That is, so when someone is using the shared data, other is not allowed to use that shared data. As we are saying that operating system is the resource manager, means it must manage the resources properly. Then the third unit, it deals with the deadlocks and protection. So deadlock, that is when the deadlock occurs, that is there if there are several programs and they are sharing some resource. If one process or one process is holding some resource, another process is again holding some another resource, and if one process is needing the resource which is held by the another process, it's like if two trains cross each other at a crossing, then no one can proceed further. Similarly, if there are two processes in the system, one process concurrently running in the system, and if one process is holding some device and another process is holding some device, process first is needing the resource which is held by the other process, and another process is needing the resource which is held by the first process, then no one can proceed, no one will finish executing. So that is the concept of deadlock. So every system must provide with the certain measures for detecting the deadlocks, preventing the deadlock, avoiding the deadlock, and if the deadlock is detected, then the system must recover from the deadlock. So this unit will be covering the concept of deadlock, what are the necessary and sufficient conditions for deadlock to occur, then what are the different deadlock prevention methods, avoidance method, detection methods, etc. And protection. Next topic which we are going to cover in the unit 3rd will be protection. What does this, why protection is needed? That is, if several users are accessing the system resources, then they must not be allowed to access unless and until they are authorized to use them. So the unit 3 will be throwing light on what are the goals and principles of the protection in the modern computer system. It will be explaining how these protection domains are used to specify the resources a process may access. Then unit 4. As we have seen, as CPU can be shared by more than one processes in the system, similarly, main memory as multi-programming, when we are talking about multi-programming and we want more than one program in the main memory simultaneously, then that memory must be protected. The protection is necessary, and there must be some way of managing the memory. So there are different schemes which are meant for allocation of memory to the different processes. So paging, segmentation with paging. Then there is a concept of demand paging. Then they're related with the paging. There are certain page replacement algorithms. This, as you will understand the concept of paging, we can go for the page replacement algorithms. Then virtual memory management. You might have done the concept of, or you must have gone through the concept of virtual memory in the previous semester. That is, as till now, we were using the concept that when the program is being executed, it should be in main memory. Okay, so it should be entirely in the main memory. Okay, then and then it will be executed by the processor. But what virtual memory? It is a technique which allows the to run the program, which is whose size may be smaller than the main memory size. Yes? So that is the concept of virtual memory. So that will be how that concept virtual memory is implemented by demand paging. So that will be covered in the fourth unit. In the fifth unit, that is, as we at the main memory size, generally it is main memory is generally smaller, so that it cannot accommodate all the programs and data. So the systems are provided with the secondary storage to back up the main memory, as well as to store the data permanently. So that so the file system, what it provides, it will be providing the mechanism for online storage and access to the both programs and data. So unit 5, it will be dealing with, it will be considering the various aspects of the files as well as major directory structures. Yes. Then the next is it will be also deal with how the protection is provided, file protection is provided, because it is very necessary when we have multiple users and we want to control who will be accessing the file and how these files can be accessed. Okay. Then there are certain disk space allocation strategies which will be covered in unit 5. Then talking about the IO systems as the next IO system, that is, which is very necessary for any computer system, so that user can interact with the computer system with the IO devices. So the unit will be also covering the basics of the IO hardware, then how this IO services which will be provided by the operating system and how these are incorporated in the application IO interface. So this is about the 5 units which will be covered in the whole syllabus of the operating system. So actually there are 5 units in the operating system. Books which can be referred, actually books which are very important, I feel, is the book which is by Galvin Silberschatz, which is title is Operating System Concepts. And the second book, which is a very good book on the operating system concepts and design, which is by the Milankovic. There are many reference books which are mentioned in your syllabus. That is the Modern Operating System, second edition by Tannenbaum, and that by Dhamderi. Then there are various online material which is available. Ample material is available on the operating system. You can go for the NPTEL courses which are by the renowned faculty in several IITs. So throughout the 5 units, based on the 5 units, you can say there are 5 COs which we are going to cover. The first CO will be covering, it will be describing the different types of operating system, structure of the operating system, or concept of a process, process scheduling, concept of a thread, difference between the process and thread, and several multi-threading issues. Unit 2 will be giving the various process scheduling algorithms, performance analysis, then how to select the suitable algorithm for process scheduling. Then again, it will be explaining the concepts of inter-process synchronization, inter-process communication. Unit 3 will be describing deadlocks, deadlock prevention, detection, resolution techniques, explaining the need and mechanism of protection. Unit 4, after studying the Unit 4, the students will be able to describe the primary memory management issues, that is the main memory management issues. What are the different allocation methods? What are the different page replacement policies and page replacement algorithms? And Unit 5, it will be going for the it will be explaining secondary main memory management issues, secondary allocation methods, and the input output systems. So when I am saying about the course outcomes, that is, these are nothing but after studying the whole syllabus, students will be able to to achieve all these 5 outcomes. So this was about the introduction to the operating system and what are the objectives of the particular subject, why it is included in the syllabus, what are the applications of the operating system in detail. Thank you very much.